Hello, everyone. Okay, now again we have this nice question. Okay, this is a question about cone frustum. That's frustum. So we have a cone has height 12 centimeters and base radius 4.5 centimeters. So which means this is a cone. We have a cone. Now the base shape is a circle and the radius of the base shape, okay, we have the radius of the base shape to be 4.5 centimeters, which is the radius of the base of the cone. Okay, now the base shape. So a smaller cone is made by cutting off the top along a plane 4 centimeters from the base. So a smaller cone, this is the smaller cone, is made from the larger cone, and that can be made by cutting off the top of the larger cone. So which means we have a smaller cone, and we know that we have a larger cone. So then along a plane 4 centimeters from the base. So which means the plane along which the smaller cone, okay, is cut off, is gotten from, is 4 centimeters to the base of the larger cone. All right, so now we want to find the base radius of the smaller cone and also the ratio of the volumes of the smaller cone and the complete cone, and that of the ratio of the volumes of the smaller cone and the frustum, okay, which is the remainder of the complete cone. And that's what we have here. Okay, now let's have our solution. Now, in this case, now the first question is about the base radius of the smaller cone. So to calculate this base radius of the smaller cone, that is the radius of this cone, this smaller cone. So base radius, we have base radius of smaller cone, okay, base radius of smaller cone to be, to be r. So that is the unknown value. So, we have a smaller cone, we have a smaller cone, we have a smaller cone, okay, and we have a larger cone. We have a larger cone. So for the smaller cone, the base radius for the smaller cone is small r, okay. So now the base radius for the larger cone is big R, and that is what we have to be 4.5 centimeters. Okay, so now, then also we are given the height of the larger cone. The height of the larger cone. The height of the larger cone is given to be 12 centimeters. Is given to be 12 centimeters. That's the height of the larger cone. All right, so now we want to calculate the radius of the smaller cone. So to be able to calculate the radius of the smaller cone, so we have two shapes here, similar shapes. So we're going to employ the use of, one of the properties of similar shapes. So, when we have two similar shapes, okay, like we have a cone, we know that the corresponding linear dimension will be what? Are related. So which means that we can have here that the ratio of, so how are they related? So we have the ratio of the height of the larger cone, height of the larger cone, height of the larger cone over height of the smaller cone is equal to the ratio, is equals to, yes, the ratio of the what? Of the radius of the larger cone to the radius of the what? Smaller cone. So which means radius of larger cone divide by, now this is larger cone, okay, divide by radius of smaller cone. All right, so the height of larger cone, we have it here to be what? 12 centimeters. So that will be 12 over. Now the height of the smaller cone, listen, from the base to the top of the cutoff part, okay, is 4 centimeters. So which means the remaining height will be 12 minus 4. Okay, so and that will be the height of the smaller cone, and that will be 8. So which means the height of the smaller cone is 8 centimeters. So this will be 8. Now the radius of the larger cone, we are giving that to be 4.5. So that will be 4.5 over radius of the smaller cone, which is the small r. So to get the small r will be what we get from when we multiply 8 by 4.5 and then divided by what? 12. So the radius would be now 8 multiplied by 4.5. 8 multiplied by 4.5, that's 36. So this is 36 divided by 12, and that's what? 3 centimeters. So therefore, the radius of the smaller cone is 3 centimeters. The radius of the smaller cone is 3 centimeters, and that is the first question. All right, so let's have our solution for the second question. Now, the ratio of the volumes of the smaller cone and the complete cone. Okay, now that means we want to find the ratio of the volume of the smaller cone. Okay, the volume of the smaller cone to the volume of the complete cone. Now, if we use now, we know that because the two shapes are similar shapes, so it means that the ratio of the volume of the smaller cone to the volume of the what? Of the complete cone, all right, will be proportional to the cube of, that's to the cube of the ratio, okay, it will be proportional to the ratio of the cube of the radius of this of the what? Of the smaller cone to the what? To the radius of the larger cone. Or it could as well be the ratio of the volume of the smaller cone to the volume of the what? Complete cone will be proportional, okay, or it will be equal to the what? To the ratio of the cube of, that's the third power of the height of the smaller cone to the third power of the height of the what? The larger cone. So what I'm saying is that now volume of smaller cone ratio volume of larger cone. The volume of the smaller cone, okay, over the volume of the larger cone. Like I said, now, when we talk about proportional relationship when it comes to similar shapes, okay, we have that in this case when it comes to volume. So the ratio of the volume of the smaller cone, okay, over to the volume of the larger cone, okay, will be equal to the cube or the third power of the ratio of the ratio of the radius of the smaller cone to the radius of the larger cone. Because in the case of volume, okay, the ratio of the volume of a smaller shape to a larger shape is always equal to the cube or the third power of the ratio of the linear dimension of that particular shape. So in this case, we're going to have the radius of the smaller cone. So we have radius of the smaller cone divided by radius of the what? Of the larger cone. So in this case, now, what is the radius of the smaller cone? Okay, so radius of the smaller cone divided by the radius of the larger cone raised to the power of 3. Okay, so in this case, we're going to have the ratio of the volume of the smaller cone to the volume of the larger cone to be radius of the smaller cone, which is 3, and then the radius of the larger cone, which is what? 4.5. Then we raise that to the power of what? To the power of 3. Now, what is 4.5? Okay, let's get what is 4.5 to the third power. Okay, that will be 729 over 8. 729 over 8. So this will be, so we're going to have this to be 27 over 729 over 8, and this becomes 729 multiplied by 8 over 729. Okay, 27 divided by, okay, 729 over 8. When we have a whole number, when a whole number is divided by what? A fraction. Okay, we're going to keep the whole number, then we change the division sign. That's okay, we change the division sign into multiplication sign. Then we now flip the fraction. So that means we flip the fraction under. which is the 729 over 8, and that becomes 8 over 729. Now we know that 27 out of 729, that will be 27, because 27 raised to the power of 2 is 729. So which means the volume of the smaller cone over the volume of the larger cone would be 8 out of 27, and this is the ratio we are looking for. All right, now let's have let's have our third solution. Now we want to find the ratio of the volumes of the smaller cone and the frustum of the complete cone. That is it. So we want to find the ratio of the volume of the smaller cone to the volume of the frustum. So this is what we are required to find out. Okay, so in this case, we know from here that volume. Okay, let's find what is volume of frustum. Okay, volume of frustum will be volume of the larger cone minus the volume of the smaller cone. Yes, VL minus VS, that's volume of frustum. Okay, so but what is the volume of the smaller cone? The volume of the smaller cone, from what we have here, V smaller, okay, over V larger, that will be, that's to get the volume of smaller cone in terms of volume of larger cone. So that will be volume of smaller cone will be equals to 8 out of 27 multiplied by what? Volume of larger cone. So this express the relationship between the volume of the smaller cone and that of the what? Larger cone. All right. So in this case, all right, so we have the volume of the smaller cone, which is now 8 out of 27 multiplied by the volume of the larger cone. So, and we want to find out what is the ratio of the volume of the smaller cone and the frustum of the complete cone. So in that case, so which means when we say Vs over Vf, Vs over Vf, okay, would be what we have as volume of the smaller cone over VL minus Vs, because VL minus Vs is the volume of frustum. So in this case, we know that Vs is what? 8 out of 27 multiplied by volume of the larger cone. So which means the volume of the smaller cone ratio the volume of the frustum will then be 8 over 27 multiplied by the volume of the larger cone, because Vs is what? 8 out of 27 multiplied by the volume of the larger cone. So then we have the volume of the frustum. So for the volume of the frustum, okay, for the volume of the frustum will be volume of the larger cone minus 8 over 27 multiplied by volume of the larger cone. So we can simplify this. You know, this is just like when we have one volume of the larger cone minus 8 out of 27 times volume of the larger cone. And that would be, so that's going to be 27 minus 8. Yeah, 27 minus 8. To simplify that, when the denominator is what? 27. So we then have volume of the smaller cone ratio volume of the larger cone to be 8 out of 27 times VL over, yes, that will be 19 over 27 VL. So VL will cancel out. So we are left with this fraction. So the volume of the smaller cone ratio the volume of the larger cone is what we are going to get when we have 27 over what? 8 over 27 divided by 19 over 27. That's division of two fractions. So in this case, we're going to change the division sign into what? Multiplication sign. So the one under, the fraction which is under, will flip and it will become 27 over 19 when we multiply it. So we're going to have multiply 8 out of 27 by 27 over 19. So 27 will cancel out, so that the volume of the smaller cone ratio the volume of the larger cone would be 8 ratio 19. 8 ratio 19. Remember, volume of smaller cone over volume of frustum is what? 8 over 19. We can also have it this way. Okay? We can also have it that way. So remember, the first one is to calculate the base radius of the smaller cone, and the base radius of the smaller cone is r, which is 3 centimeters. And the second question is to find out the ratio of the volumes of the smaller cone and the complete cone. So, which means the complete cone is when we talk about the larger cone. So, volume of the smaller cone over volume of the larger cone will be equals to the third power of the ratio of this of the what radius of the smaller cone, okay, to the radius of the larger cone. Remember, in the case of volume, okay, the ratio of the smaller volume to that of the larger volume will be equal to the cube or the third power of the linear dimension of the what of the shape. And the linear dimension are the length or the height or the radius. So we have radius and height in this case, okay, and that's what we have as 8 out of 27. Okay, so then the third question, which is question C, we that is to find the ratio of the volumes of the smaller cone and the frustum. So we have here that volume of frustum is volume of the larger cone minus volume of the smaller cone, and then we have this solution. Okay, now the noblest pleasure is the joy of understanding. Bye bye.